Good morning, guys. This is Mr. T, and I'm going to guide you through this station, which is on quantum numbers. First quantum number that we're going to talk about is the energy level number, or N. N is the number that you see next to each level, and it represents the energy level. So for example, for 2s, N equals 2. For 3p, N equals 3. For 4d, N equals 4. The second number is the L number, which represents the shape of the energy level, and is correlated to the letter next to each level. Each letter has a corresponding L number. For example, for S, L equals 0, for P, L equals 1, for D, L equals 2, and for F, L equals 3. The next number is the ML number, which is related to the L number, and it adopts values from -L up to +L. So for example, for L equals 0, ML can only be 0. For L equals 1, ML can be either -1, 0, or +1. For L equals 2, ML can be -2, -1, 0, 1, or 2. And for L equals 3, ML can be -3, -2, -1, 0, 1, 2, or 3. The last quantum number is ms. ms is related to the spin of the electron. Basically, if the arrow is pointing up, ms equals +1/2. If the arrow is pointing down, ms equals -1/2. So now let's look at some examples. Let's start with chlorine. When you look at the periodic table, the atomic number for chlorine is 17. That means that chlorine has 17 protons and also 17 electrons. This means that we will have to fill up the orbital diagram with 17 arrows representing those electrons. So in order to fill the diagram, we start from the bottom following the Aufbau principle. The first level at the bottom is 1s. We're going to fill up that box with 2 arrows, one pointing up and one pointing down, following Pauli's exclusion principle. Next, we're going to go up to the next level, which is 2s, again filling it up with 2 arrows, one pointing up and one pointing down. We're also going to fill up the 2 next levels, 2p and 3s, again with all boxes filled up with arrows pointing up and down. And for the last level that we're going to look at, which is 3p, we're first going to fill up each box with only 1 electron, which is represented by the arrows pointing up, and this is because of Hund's rule. Then we're going to fill up the 2 last electrons that we need to achieve that 17 number. And the last electron that we fill up, you can see it highlighted there in yellow, is going to give us the quantum numbers that we need. So when we look at that last electron, we see that it's on the energy level 3p. So for the energy level 3p, the N number is going to be 3. For the 3p level, if we look at the letter p, that's represented by the L number equal 1. For the ML number, we have to put on top of those boxes the possible ML numbers according to P, which are going to be -1, 0, and 1. Remember that P equals 1, and ML goes from -L to +L. And then we're going to see where the last electron that we filled up lies in. And in this case, it's below the 0. So our ML number is going to be 0. The last number that we have to fill up is the ms number, and in this case, since the arrow is pointing down, it's going to be -1/2. Let's do this again with another example, in this case manganese. If we look at manganese in the periodic table, then the atomic number is 25. This means that we will have to fill up the diagram with 25 arrows in this case. So what I did here is just start from the diagram that we use for chlorine, so we have all these levels filled up in the same way that we did for chlorine up to 3p, with all the boxes filled up with 2 electrons, one pointing up and one pointing down. The next level up is going to be 4s, which we fill up again with 2 arrows. And then we're going to go up to the next level, which in this case, do not get confused, it's not going to be 4p, it's actually going to be 3d right next to 4s. So again, following Hund's rule, we are going to fill up each box with 1 electron, in this case pointing up in each case, and we already reached the 25 that we needed. So we're going to look at the last electron that we filled in these boxes, And we're going to see that it's the last arrow on 3D pointing up. So once again, we're going to decide what's the quantum number for n. N equals 3 because the energy level is 3D. The L number in this case is going to be 2 because the letter associated to that level is D, and D corresponds to a number 2. Then to decide what ML number we're going to use, we're again going to go from minus L to plus L with one number per box, going from minus 2 to 2. So you can see there on top of each box we have a number from minus 2, minus 1, 0, 1, and 2. And we're going to look where the last electron that we filled up lies. In this case, it's on the box labeled with the number 2. So that's going to be our ML number. And the last number that we need is the MS number, which in this case, since the arrow is pointing up, is going to be positive 1/2.